Good morning, class. Today we're going to move into lesson 4.3. And as we learned in the first couple lessons, not everything is as it seems. We don't always use a base 10. Sometimes we use other bases. We looked at the Babylonian, the Mayan methods of using different bases. There are a couple of other ways that we can take this as well. So let's take a look at some other bases. Base 10 is the most universal. Hindu-Arabic system is kind of found pretty much throughout the world. A lot of it's the concept here that people have 10 fingers generally. And so when we use base 10, we have 10 to the 4, 10 to the 3, 10 to the 2, 10 to the 1, and 10 and 1. All right, so I'm sorry, 10 and then 1. Base 2, some groups of people in Australia, New Guinea, Africa, and South America still use this. Very commonly used in computer programming. We call this binary language. And you can see here, again, we have 2 to the 4, 2 to the 3, 2 squared, 2, and then 1 as our base. Sometimes we use bases 3 and 4. Some areas of South America use this system. Again, 4 to the 4, 4, 3, 4, 2, 4 and 1, same with a base of 3. So I hope you're seeing a pattern here. Base 5 is used by some primitive tribes in Bolivia. We have 5 fingers on one hand, so that seems like kind of a reasonable thing to do. Base 6, sometimes used in Northwest Africa, occurs in other systems in combinations with 12, the duodecimal system. And we kind of see 12s and 6s quite often. 12 inches in a foot, 12 months in a year, 12 hours in a day. A gross is a 12 by 12 area. So you can see that base 6 also shows up. And then base 60, as we talked about with the Babylonians, we still see this a little bit today, 60 seconds in a minute, 60 minutes in an hour, 60 minutes in 1 degree, when we're talking about measurements of degrees. So these bases do appear still, and that's why it's important to understand how to decipher them. So to start with, we are going to look at converting to base 10. And so here we have something that's, it's 524 with a base of 6. So what do we do there is we take each of the different values, 5 and then 2 and then 4, and we have to multiply it by its corresponding base 6 number. So remember, base 6 is going to be 6 squared and then 6 to the first and then 6 to the 0. So you see 5 times 6 squared plus 2 times 6 plus 4 times 1 gives us 180 plus 12 plus 4 gives us 196. Ooh, it's not so tough. Next one, 3,615 base 8. Convert that to base 10. Same thing. We have a 3, a 6, a 1, and a 5. So we take the 3 times 8 cubed, because it's the fourth value over. 6 times 8 squared, 1 times 8 to the first, and 5 times 1. We're going to get 1,536 plus 384 plus 8 plus 5, leaving us with 1,933. So that is how you convert to base 10. A couple more examples here. With a base 12, in base 12, T equals 10 and E equals 11. So here we've got our first part here, 1 times 12 cubed, then 2, that's this 2 right here. I don't know if you guys can see my mouse, I don't think you can. 2 times base 12 squared, and then 10 times times 12 to the first, that's what the T stands for, and then 6 times 1, 1, 6 at the end there. So that's going to be 1,728 plus 288 plus 120 plus 6. So the grand total, 2,142. Another example, this is our binary language again, 101101. So it's 1, that's the first number out front here, times 2 to the 5, 0 times 2 to the 4, 1 times 2 to the 3, another 1 times 2 to the squared, 0 times 2, and 1 times 1. Gives us 32 plus 8, plus 0, plus 8, plus 4, plus 0, plus 1, total of 45. So this 101101 is how you would write 45. Whoa, cool stuff. So now kind of going the other way, taking a base 10 and converting it to different bases. We have 406, which is base 10, converting it to a base 8. 273, converting it to a base 3. 558, converting it to a base 12. And 56, converting it to a base 2. So we start with 406 to base 8. Well, normally it's written, 406 base 10, but we don't use this little 10 here because we don't need it. So base 8, we have 8 cubed, 8 squared, 8, and 1. which is 5, 12, 64, 8, and 1. We want to take the highest power of 8 that is less than or equal to 406. That's 64. And so we're taking 406 divided by 64. It's going to get us 6. So that's the first digit. We have a remainder of 22. Our remainder of 22, okay, we're going to divide that by 8, because that's our next number down. Well, 22 divided by 8 is 2, with a remainder of 6. So that's our second digit. There are two groups of 8 and 22 and 6 units remaining. Since the remainder is less than the base, no further division is required. Since we have remainder 6, and 6 is smaller than 8, we don't have to do any more division. Now we just have that 6 left over. So 6 is our final digit. How we put this together, 6 was our first digit, a 2 was our second, and a third was a 6. And so we have 6 times 64 plus 2 times 8 plus 6 times 1, which is 6 times 8 squared plus 2 times 8 plus 6 plus times 1. So we get 626 with a little subscript here of 8. So we know we're writing this in base 8. All right, not too shabby. So moving on to 273. 273 to base 3. Base 3 uses 3, 6, 3, 5, 3 to 4, 3 to 3, 3 squared, 3, and 1, which is 729, 4, 2, 43, 82, 27, 9, 3, and 1. So we start with the largest one that fits under 273. So that would be 243, which is 3 to the 5. Okay, so we have divide first. So we get 1, remainder 30. We go to the next one, which is 81. Oh, that doesn't go in there, so we still have remainder 30. Do the next one, 30 divided by 27 goes in there 1 time. We have a remainder of 3. 3 divided by 9 doesn't go in there at all, 0 times, remainder 3. And then 3 divided by 3 goes in there 1 time, remainder 0. So the remainder is 0, which is less than the base. Base is 3. So we have no further division necessary. Well, you can see all these 1s and 0s and 1s here. We want to line those up so we can actually see what we're doing here. So we have 1 by 243 plus 0 by 81 plus 1 by 27 plus 0 by 9 plus 1 by 3 plus 0 by 1. So you see these numbers out here, 1, 0, 1, 0, 1, 0. We're talking base 3. That's our answer, 1, 0, 1, 0, 1, 0, base 3. Okay, so you got a couple here to do on your own. You got those 2 done. Pause the video real quick. See if you can figure out 558 to base 12 and 56 to base 2. Let's see how you did. So when we talk about 56, base 2, you can see here we've got this 1. Oh man, my transitions are all messed up. But anyways, that was not how that was supposed to pop, but that's okay. We'll go back in time here a little bit. So I've got 12. When we use a base 12, we're going to get 3 times 12 squared plus t times 12 plus 6 times 1. So we have 3t6 with a base of 12. And then the second one here, 56 to base 2. When we do 56, first thing we can divide by is this first one here, 2 to the 5th, which is 32, and then 16, and then 8. We have nothing left over in the last 3, so our number is 1, 1, 1, 0, 0, 0, base 2. Whew, that was kind of a quick run through. I don't think that this is going to be too challenging. Just remember, you're going to divide by the biggest one you can divide by, and then whatever you have left over, remainders, you're just going to keep working your way down the ladder until you get it all the way broke out. Okay. For your homework, it's pages 164, 165, and I tried to be selective on this, so it's not all of them, obviously. It's going to be a bunch of them. So this will give you kind of a smattering of practice for each of these. Do your best. Good luck, and I will see you in class.